Welcome to the John Postel series. And it's my honor to introduce the speaker today. Maja Matarić is a chaired and distinguished professor of computer science with appointments in neuroscience and pediatrics at the University of Southern California and principal scientist at Google DeepMind. Her PhD and master's in computer science and AI are from MIT, and her BS is in computer science from the University of Kansas. She's a member of the National Academy of Engineering and the American Academy of Arts and Sciences, fellows of AAAS, IEEE, AAAI, and ACM, recipient of the Presidential Award for Excellence in Science, Mathematics, and Engineering Mentoring from President Obama. And a long list of awards that I will not continue. But I wanted to highlight that Maja's research actually pioneered the field of socially assistive robotics, and we'll hear a lot more about that today. One last anecdote I wanted to share is that Maja mentioned that almost 20-some years ago, she almost joined UCLA, but now she's at USC, and we're glad we can have her here today to give us the talk. Okay.
Thank you. It's wonderful to be here. It's not that I turned UCLA down, but the dean didn't want to spend money on robotics. I'm glad to see that has changed. It's a different dean. But anyway, this was a long time ago. And actually, when I first started at USC, I was an assistant professor, and I got invited to give a talk, not in this building, I don't think. But this is a very memorable experience because I had an old, like a Sony Vaio laptop. This means nothing to the young people. But anyway, I drove to here from USC, which is not close. And then I realized that I didn't have the special dongle to present. So I had to call my first PhD student and ask him to drive across LA to deliver this for me. And I thought this is so inappropriate to ask a student to do that. But, you know, he still graduated and he was my first. And hopefully I don't ask crazy things of my students anymore. Well, I do, but it doesn't have to do with driving. So anyway, so I have a lot of great memories. My middle kid got a degree from UCLA. It's all good. It's lovely to be here. Lots of good friends. So I'm going to give a talk that kind of overviews a bunch of stuff that we do in this field of socially assistive robotics, but also more broadly about AI and training models and things like that, because I have, you know, a little bit of a foot in industry. I've seen a few things. And then what I just want to say for the students in the audience, you have my absolute commitment that I will answer every question you have. So you are welcome to stick around if you don't want to say it out loud. There are always 30 people after the talk who have questions. Just realize I'm a resource to you. Please ask me. If you email me later, I may not get to it. Email is the bane of my existence. So, you know, please approach and ask questions. Okay, here we go. Anyone notice that we're in the age of AI? It's a really wonderful thing. For those of us who have been around for a long time, it cannot be claimed that we predicted it. People will say things like, oh, we knew this was going to happen. Well, they didn't know when. And nobody knew how. So it's a really interesting time as a field, computing. We have created this thing, these amazing models. And now we're spending a vast amount of our time poking them and seeing what happens. So that's sort of like an interesting thing. It's like we've created a thing, we don't understand it, and we're poking it and also figuring out where to push it into the future. And what I'm going to argue a little bit is that if we really are trying to create AGI, so artificial general intelligence, which, you know, you all know what that is, and we all know that there's a race on for that. We need to look at how other examples of intelligence actually worked. How would you even know that it's intelligent? What does it mean for something to be intelligent? So let's look at human intelligence. That's our best example. And human intelligence evolved in a context, in an evolutionary context, right? And also developmentally. So a creature is intelligent in the context of its body and its environment. There's no such thing as being intelligent without those contexts, as I'll argue. So intelligence is embodied and situated. And it turns out that the social interaction, how we relate to one another, that was a huge driver of human intelligence. We are literally as smart as we are, and we think we're pretty smart as a species. We're as smart as we are because of the complex social structures that we have. It's the social structures that drove the evolution of language, which drove further evolution of reasoning. So that these are really important things, because underneath it all, the social thing, there is a physical thing. So intelligence is a symphony of the physical, cognitive, and social and socio-emotional. And so I'm going to talk about why that's really important, because you might notice that some of these bits are missing in the current models. So achieving AGI is going to require these other things. It's going to require embodiment. Whoa, not everyone agrees with that, but we will discuss it. And it's going to actually require the social bit as well. And almost no one is thinking about that yet. So, we're training models as a society. There's a lot of investment into collecting data and training models. But there's also a lot of debate as to whether the data we're collecting are actually the right and useful data for training these models. We need to be collecting data in complex, interactive, dynamic scenarios, like social interactions and so on, physical interactions. This stuff is really, really hard. And it's also really hard to simulate. So, when people are all about sim to real, trying to actually simulate how people interact socially, emotionally, in a setting, when you want to put a robot in a human world, you have to deal with people. Nobody knows how to simulate people. Or if you think you do, well, that's cute. But no, nobody, because no one can predict human behavior. If we could, we would maybe live in a different world. So it's really interesting, this time that we're in. We have done so much with language, but we're trying to do so much more, like with robotics, in the physical world. And it's proving to be a lot harder than maybe people would expect or hope. So we'll talk about why that is. But I'm going to switch topics. I'm going to do this on you several times in the talk. I'll talk about one thing, then I'll talk about another thing, then I'll go back to another thing. That's just to keep you awake. Suppose that we did make major progress and we could have machines in the world around us. And by that, I mean physically embodied machines. This talk will be a lot about embodied AI, also previously known as robotics. So it turns out there's no right answer. So, for those of us who've been in robotics for a long time, and putting robots in the world, people ask questions like, what should the robot look like? How big should it be? There's no right answer. So you can't just do a UX study and ask people to tell you answers to this. There's no such thing. There's no specific design or function that is going to be accepted by all or even most people. In fact, we're going to see some really bad rejecting behavior of machines in the physical world. I predict this. I learned a lot from how people behaved during the pandemic. I think it was a really interesting time. When people are stressed, when people are threatened, when people are worried, and people are stressed, threatened, and worried about AI, they behave in particular ways. We behave in a particular way. And so it's really interesting to think about what these technologies need to look like and what do they need to do in order to be acceptable to society. All of you here in this room, you're a select group because you were presumably interested in this. This is why you're here. But, step outside of the engineering quad here, and you will have a lot of your peers at UCLA who are very anti-AI. And they have good reasons for that. So we live in an interesting time. If you're not aware of this, you should be aware of it. We must not be in bubbles. So what can we do about that? What happens when we put robots with people? So there have been a lot of studies. There's this field of human-robot interaction that's about, I would say, about 30 years old, maybe more. It's my field, so yeah. So it's been around. 30 seems very old to you, I'm sure. So it's been around and a lot of studies have been done. And we know that the way people interact with robots is kind of similar to the way people interact with other people. So people ascribe agency, goals, emotions, intent to even the simplest of machines. Something that looks lifelike is going to evoke in you a lot of responses that you have to real living creatures and even intelligent creatures. You will feel kind of relatedness, you'll want to be helpful, you'll feel empathetic, but also, depending on what that thing looks like and how it behaves, you might find it really creepy. You will have what's called cognitive dissonance. The thing will fall into what's called the uncanny valley. And what happens is bullying and abuse. So here's the thing you might not know, but you could Google it on YouTube, but don't do it now, please. There are a lot of videos of people abusing robots. Some do it for fun, but some people do it because the robot is really disappointing, right? You go into a store and it's supposed to help you and it's useless and it looks like it's smart, but it's not. It's not even cute. So there's this whole interesting thing about robots because they're like us, but they're not like us. So they could be in group or out group. If you like it, you're willing to suspend disbelief. It knows things about you. It likes you. It's wonderful. Or it's creepy and you don't like it and you treat it very, very badly because it isn't another human. So you can get away with it. And that's interesting and important because we're bringing these things into society as quickly as we can, apparently. So one line of thought that I was engaging in with some philosophers is if you think about robots as life forms in the ecosystem, which is our social ecosystem, our world, how do they survive? And at one level, they survive from an economic perspective, which is they have to be affordable and they have to do something useful so that people will want to pay for them. And that's why a lot of robotics companies lately that were doing kind of in-home robots have failed because the robots were fun and cute and useless, completely useless. And people were like, well, my phone does more than the robot. And the robot is much more expensive. So you have to have a value proposition. However, it's more than that. Once you bought into it, you need this use case, right? It needs to actually, the currency here is emotion. You have to want to not turn it off. And we have not achieved that at all as a field. Like we have not really created things that people really care about that much. And it's not enough that you just invest in it. This is why people abuse and bully them because they're not really creating value yet. So how we might get there, there's some insights on that I want to tell you about. And one of them is this notion of how can you create a machine that people will feel cares about them? Because if you feel that something cares for you, then you want it. You want it to, it's like it's giving you value, makes you feel good. And there are a lot of things that we can do in the health and education space that will give that value to the user. But it's really hard. And I just want to put this out there, like for the students to think about. A lot of technologies that we're creating now, not just robotics, like across AI, are meant to replace human work rather than augment it. And I just want you to think now and then often about what are you creating? Are you creating things that are replacing human work? Or are you creating things that are supplementing the human's ability to work? Because if we only focus on replacement, what are people going to do? And I know you all want to think, well, some decades from now, it'll all settle out. What's happening in between? And that is your timeline, right? So think about the need for balance between automation and augmentation. If we're only doing automation, what are you doing? What are you going to do in 10 years? I don't want to be doom and gloom, but you have choices. You specifically, all of you in engineering, you have choices in what you choose to work on. And I think people often end up kind of on a rail. You're just doing what you're doing, you keep doing it, and you're just doing the next decision, the next one. It's not very intentional. Think about it. Think about the implications of what you're working on. You'll have a choice. You're the talent. So do something cool and meaningful. The goal of the stuff that we do in our lab, I believe, is cool and meaningful. We like it. And the idea is to really study human-machine interaction, in particular human-robot interaction, to create these really personalized therapeutic interventions, right? They could be for physical rehab. They could be for cognitive stuff. Usually it's around cognitive and social emotional stuff. So I'll show you a bunch of different systems that were done over the last 20 plus years in the lab. It's a very different kind of robotics, this field. People often haven't even heard about it. I like it. People come up to me later and say, I didn't even know this existed. Okay. So this field of socially assisted robotics, what is it? So it's machines assisting people in doing things that are hard for people, but the machines are not actually doing the work. So, for example, if you think about physical rehab, you might want to move the arm of a stroke patient to let them practice. Or you might want to feed a person who is maybe paralyzed and cannot feed themselves. That's physically assistive systems. We are talking about socially assistive systems. So we're talking about the robot understanding the user in real time, understanding their needs, and then helping them help themselves. Practice the stroke rehab exercises. Practice social skills for individuals on the autism spectrum. Practice cognitive behavioral therapy because it's hard and you need it for emotion regulation. A whole bunch of domains that I'll tell you about. So we're going to talk about why does it need to be a robot, why this is important, and why this is hard. But I just love this. Back in 2009, when the field was relatively new, there was an article in the New Yorker about it. And I just think it's really fun, first of all, to use that wonderful image that someone paid to make. But robots that care, that's a good handle for what this is about. So why does it need to be a robot? Why can't we just use an app? Is there an app for that? Why do you need to use a robot? Robots are expensive, they're complex, they're in the physical world, they're not very useful right now. Why do we need a robot? There's a very simple reason why, with over 50 years of neuroscience evidence. Your brain is in a very different state of activation when you're interacting with the screen than when you're interacting with something in the physical world that is co-present with you. It's a vast difference. Not only are many more areas of your brain engaged in an interaction in the physical world, even if it doesn't involve physical manipulation, if it does, even more so, but it doesn't have to. But there's much more activation. So we already understand this about the brain. Like, if not a lot is going on, not so great. If more is going on, probably good until it's a seizure in the limit, right? So we are physical creatures. We evolved to be physically in the physical world interacting with one another. That's why touch is so powerful. That's why you got to touch babies. When you don't hold babies, they literally have developmental delays. This is a very old, this was shown in cruel studies with monkeys decades ago. We don't show that with actual human babies because we'd be super cruel, but you got to do it. You got to have touch. And also with babies, you got to have eye contact. If babies are not getting human eye contact, they have developmental delays. We have a study in our lab working with Children's Hospital Los Angeles looking at interactions between moms and babies at 6 months, and in particular moms that are stressed and not making eye contact. We could predict developmental delays a year later with 90% accuracy. Okay, so these developmental steps are super important. Your brain's engagement is super important. How engaged is your brain? How much of your life is spent doing the thing on the left? Think about it. So I got so tired at some point in my career of answering this question of why does it have to be a robot? Could it be just a simulation on the screen? Couldn't it be a simulation on the screen? So we did a large-scale metadata analysis of all the work that had done human robot versus human screen agent comparisons. There were a lot of studies, a lot. And we did some beautiful plots, and I'm not going to explain all of that other than to tell you, check out the paper, and next time someone asks you, why does it have to be a robot, just point them to this paper. Basically, the outcomes for human physically embodied interactions are incredibly powerful, statistically significant, with power, that people engage more, learn better, retain their information better, recall the interaction as being more pleasant. All of these things conspire. Why? Because we're wired as physical and social creatures. When you take the physicality and the social bit out, you lose a lot. So keep that in mind when you think about these models and when you think about products that the models are being used for. So now I want to give you some examples. This is an example of when you need, oh dear, we don't need to listen to this yet. I don't want to train you. Okay, stop. All right, we're just going to let it play, but you can't hear it, hopefully. All right, so we do a lot of things in the lab, but we're generally inspired by, oh, there's a problem, we don't know, nobody knows how to fix this. Wouldn't it be cool if we could insert a robot in the equation and see if we can fix it? Here's a great problem. If you have babies that are at risk for movement development delays, for various reasons. Maybe they had a difficult birth, or maybe, they're at risk because of siblings on the autism spectrum, various reasons, right? So I want the baby to kick higher or move, her left arm higher. How are you going to do that? You're going to tell the baby to do it? Doesn't work. Are you going to show the baby how to do it? Doesn't work. You're really big, the baby's small, doesn't care. It's going to look just at your face. So how am I going to get the baby to be coached? I want to coach the baby. So it turns out if another baby could coach the baby, that would work. But I don't know how to get the first baby to be a coach to the second baby. So, but you could use a robot. So we discovered that if you use a robot that is basically baby-sized, the babies are very interested in this because it's kind of salient and it's kind of their mirror neurons, this mapping mechanism of body to body, induces them to imitate what the robot is doing. Again, if you do this with an adult, it doesn't work. Babies don't imitate adult bodies. They do imitate facial expressions to some degree, but not bodies. But they do imitate a robot. There's a little bit going on there with a vision model, a deep model that predicts where the baby will look, which we need to use to kind of drive their, because the baby won't necessarily look at the leg that's kicking, because whatever, it's all the same to the baby. They don't know that's important. So that's why we use this little bell to also give them a little bit of extra reward. But anyway, what we did was we used the robot to puppeteer a baby, to get the baby to exercise. Now, let me just explain to you in case you're not seeing this. There is no other way that any of you could make that baby do that. Tell me how you would do it, literally, other than moving the baby physically. That's out, not allowed. That's not, because by the way, if you do move someone's body physically, they are feeling what you're doing, but if they don't want to move, they're not going to learn. Like in rehab, putting someone through doesn't actually help them until they want to move. Another thing about our brains, the motivation is critical. So there's no other way to make the baby do that. So this is a really interesting example of two things going on. One, embodiment. You cannot show this to the baby on the screen. I mean, I don't need to tell you that little babies, they watch screens, their visual cortex lights up, they don't learn from anything. They have to get to a certain developmental stage before they can learn information from a screen. So there's no other way to do this. This physical embodiment is fundamental. But it's also a social thing. The baby is engaged with the robot because the robot looks like another baby. It doesn't work if you put a stuffed bear or a ball. I don't know how you use a ball to move the arms, but the point is there's a social and an embodied physical component, which is super interesting. Anyway, I just think how else? Think about it. Tell me later how else you would do this. So then the natural question becomes, well, what's the right embodiment? What should the robot look like? So one of my just amazing, amazing students, Nathan Dendler, on the job market, y'all should hire him. That's amazing. Anyway, one of the many things Nathan did for the dissertation was to look at various embodiments and look at what was the predictor of acceptance. It was the expectation of what people thought the robot could and couldn't do. And the expectations were really interesting because they had to do with what people's experiences in the real world were. Like if it's an animal-like robot, people don't expect it to be terribly smart, but they kind of like it. If it's a humanoid robot, then people have great expectations of how smart the robot will be, which is a real bummer for people developing humanoids right now. Huge expectations that these things will be smart, and they won't for a while. Also, huge expectations on dexterity, that like humanoid robots should move like humans, smoothly and nicely, and they don't. And then also amazing biases around gender. So we found a whole bunch of really interesting things, and by we, I mean Nathan. So this is a really, really nice piece of work because one of the things that Nathan did was create this space of different embodiments and populated by the embodiments that have been created with people's impressions. And then you can look in that space and say, well, if I wanted a robot with these kinds of responses for people, what might it look like? So it's a really cool tool. And yes, we did look at different embodiments and bias, another piece of work from Nathan. And just looking at, like, if you have a robot that is dressed slightly gender differently, otherwise it has the same underlying embodiment, how do people perceive it? It turns out the voice of the robot is the best predictor of the gender perception. So it's not what the robot looks like, it's what it sounds like, which is really interesting, right? You wouldn't expect that, but that's what people do. But if you make the voice androgynous, then the next thing is the clothing and what you tell them. Like, if you tell someone it's a nurse, they think it's a female. If you tell them it's a doctor, they think it's male. Yes, still in 2026. This study was in 25, so actually in 24. But it really interesting stuff around what the form factor of the robot is and how it affects expectations on function. We also looked at voice, right? Because I just told you the voice is really important. Big parts of your brain, second to vision, are developed to deal with voice. So we looked at whether specific kinds of voice would map to different bodies of robots or disembodied robots. And the big takeaway here is really that there is no clustering of people's preferences. So again, when you're working for a company and you're developing a product, what the company wants to do, every company, is to run a UX study from some end people and say, oh yeah, people like this, we will just go like with the clustering of what most people like, and that's how we'll set up our product. Well, it turns out when it comes to voice and embodiment, there is no clustering. People like all kinds of different things. So you can't give people their top choice. What you could do is do one of two things. You can basically have a generic choice and people won't like it. Or what you could do, and I think this is really interesting, we let them adapt it just a little bit. We didn't give them like a giant space of features to adjust, just a little bit. As soon as a user is able to adjust a feature on the robot, even a little bit, they're very happy with it. They're as happy with it as a human voice. This is not about what they're adjusting. This is, again, about people having autonomy. So it's a really big hint because companies today are still doing a bunch of UX. And then they're like, what's the personality of Gemini? What's the personality of ChatGPT? This is all determined by UX. But you can't average over all humans. So it's very interesting to think about when do you want to personalize? And that's a lot of my talk is going to be about how do you personalize? How do you use models to personalize and so on. All right, speaking of personalizing and personalities, 20 years ago, we've always been interested in motivating people. And so 20 years ago, we worked on some modeling of human personality. So how would I make an extroverted robot? Well, there's a principled way to do it. What does it mean to be extroverted? Well, it turns out if you're an extrovert, you talk a little faster compared to average, you gesticulate more, you get closer to people. There are a bunch of features of extroversion that are well described. So we created robots that had those features. And then we just had people interact with them in the context of rehab exercises, seated aerobics, as you might call them. And we found a really strong effect. When the personality on the extroversion-introversion scale was matched to the user, people did a lot more exercises and they said, I like that robot. We didn't tell them it was extroverted, introverted. For the introverted robot, the opposite. And what we found was the extroverts would say, I like that one. Introverts would say, I like them both equally. But they did a lot more exercises with the introverted robot. So even in these subtleties, our personality and what we find or who we find synergistic is driven by who we are and the personality of the robot. This was 20 years ago. Sometime in the meantime, Google went and patented personalizing. I can't do it. We had a previous paper. But okay, I work with them now, so it's okay. So now it's a huge deal. Personality in models is a huge deal. How do you express a person? What's the right personality? What's the tone of a model? Should it be extroverted? Should it be introverted? Should it be like the dark triad? Should it be psychotic and non-conscientious? Probably not. So there's a lot of work behind the scenes on models right now in terms of personality. We just had a paper come out in Nature Machine Intelligence on how you properly prompt personality. So if you want to have a model with personality, refer to this paper. But it's very interesting. It's kind of like exciting times right now, people deciding how models should behave. But companies that really understand, going back to my 2 slides ago, you really need the choice to adjust your model to what you like. There's certain personality profiles that are more agreeable, they're liked by more people. So extroverted, agreeable, open, conscientious personalities are generally easier to interact with, like that's what you want. Whether you're doing commerce or being coached or whatever it is, that's what you'd want in your agent. But not always, and not all the time, and not for everyone. And so this idea of how might you actually create deep binding in a model, so not only does it give you 2 or 3 turns of language interactions with actual personality, but downstream, it really behaves that way. That's a really big open problem right now in models. Kind of love it that we did it 20 years ago. We're back. And then it's even more than personality. It's really personas, right? So it's not just how he talks to you. It's like an entire persona that you're interacting with. And so there's a backstory. And this too we worked with, okay, not 20 years ago, but maybe 15 years ago, when we were creating robots for kids. In one case, kids with type 2 diabetes, getting them to exercise. In another case, first graders, getting them to eat healthy foods. So what was the backstory for the robot to get them motivated? And it's really, really interesting what you find out, what people will believe and not believe. Like with the robot on the left, there were a bunch of exercises the robot had to do. That's my student Kate. That is not one of the study participants. Kate clearly is not a participant that needed this. But the interesting thing is that there are a lot of things we said. My name is Vega and I'm from planet whatever, and I can't do jumping because my planet has different gravity. Boy, we spun quite a yarn. And that was fine. People were okay with it. Of course, you don't really believe it, but you're okay with it. But then the robot says, oh, I understand what it's like to be overweight. I used to be overweight too. Nobody believed that. Nobody believed that the robot was overweight. Why? Because it's a robot? But it's from planet Vega? No. It's about the fact that being overweight is a very visceral, personal thing. So when you build these personas, you have to think about what is really sensitive for the user, because that's the area you don't go into, because they're not going to believe it. But it depends who you are. For some people, sure. For other people, no. So this personalization becomes very important. We did the same stuff with first graders. Super fun. We created these competitions with their sibling. I won't bore you with it. But anyway, again, here we are now in the age of models, and this is exactly what's happening. a lot of work with LLMs and foundation models more generally, multimodal, is to create personas. Why? Because we might want to do social science experiments. Instead of doing it on MTurk, you can use models to test theories, but you need to model people. You want to simulate people with models. How do you do that? How do you create these personas that are actually predictive of real humans? That's all science now. And it's really interesting stuff. So, we and many others have published in this space. It's interesting because it can really create a possibility, an opportunity to do a lot of testing and evaluation, but only if you do it right. Like the thing you cannot do is just tell a model, be extroverted and tell me this. Sorry, that's not principled. Or you are a Midwestern housewife who is 50. Okay, now answer this question for me. That's not science. But that is still what most people are doing with models. So this, it's like, again, the science of prompt engineering. Empathy. My friend asked me about empathy earlier today. So empathy is a really interesting thing. Not only is it good when you're empathetic to someone else, right? Like you're like, oh, I'm sorry you're in pain. Turns out it's really good for you. So even if you're an utterly selfish person, no such people in this room, but if you're an utterly selfish person, it's really healthy for you to be nice to other people. Shocker. We're evolved to be social creatures. When you're nice to someone else, you get a boost internally. Wow, good thing, try it. So we were interested not in creating robots that look empathetic to people. That's easy. It's very easy to create a robot that says, oh, I'm sorry you're not feeling well. I mean, we've all heard about sycophantic models. It's very easy to do that. What's more interesting is what should the model/human do, a robot do, to make the human behave empathetically? Because empathy is good for people and it's good for society. So how do we do that? So we did a bunch of studies where we had people talking to robots, and I'll tell you just about two. One was looking at robots talking about themselves versus talking about other robots versus talking about people. And we found that humans in our studies, are most empathetic towards robots that talk about humans. So we kind of inherently feel that human connection. We care most about humans still today. I don't know for how much longer. It's kind of interesting. Also first person versus third person. Like if I'm telling you a story about me, versus if I'm telling you a story about my friend Beth, you care about me more. So this indirection that happens. And then also, getting them to actually make an action that's some kind of an empathetic action. So it's really interesting because we then use some deep learning to actually predict whether when people said they were feeling empathetic, they were actually feeling empathy based on their facial expressions and got very strong correlation. So that was interesting. But then perhaps more interestingly, we created a scenario in which the robot needed to elicit empathy because it was constantly failing. And so we had this robot and it was trying to do something. And you, as a study participant, are working on the computer. You're doing something. We gave you a task and you think that's what it's about. But then there's this robot and it's doing something and it's failing constantly. So how that robot asked for help is an interesting study on empathy. So we had 3 different personas for the robot. We had like a normal, neutral robot persona. I've detected a physical contact with a wall. My main vision functionality is affected. Can you help me? Versus, I usually see quite well, but the darkness has taken me. This was like the humor of my postdoc. Please do not judge. The force is just not strong with this one. Anyway, it was supposed to be funny. And then the last one was sad. Oh, I'm afraid I might have come apart. I need to get fixed. I'm really scared. So, what do you think people would be most empathetic to? By empathy, we measured how often people were willing to quit what they're doing and go over and help the robot. And then quit again and help the robot. How many times over 45 minutes? It gets really boring. But that's an actual functional measure rather than me asking you how you feel. And I thought that the sad robot was so annoying. But who am I to say? It turned out that the sad robot was by far most likely to get empathy from users, whereas the funny robot was greatly disliked. And then the neutral robot was like, blah. So that's interesting. But I think what that tells us is not that sad robots are the way we should go, but instead that this is all very situational. The person in the study was not doing anything high stakes. If you're doing something high stakes, like if you're at the doctor's office and the robot receptionist is super incompetent, I don't think you're going to be empathetic. So this contextual component is really important. It's not coming through necessarily in some of the model work that people are working on. But anyways, this notion of how do you turn on people's empathy? It's a very important thing. People are trying to manipulate empathy and engagement a lot. And it turns out to be, sometimes unexpected, even for us. Your natural tendency is to be empathetic, but it's how you tweak the interaction. This is going to be really important as we put robots in the world, because the robots are going to be very imperfect. And if you don't feel empathetic and patient with this machine, you're going to be disappointed a lot and frustrated, and you'll kick it and you'll return it, and companies will be sad. And this idea of vulnerability, it evokes disclosure. So we've also worked on, we had a grant to create robot mediators for support groups. You might say, why can't people mediate support groups? People do, but people get burned out. It's a really hard task to have a group of people who are suffering from something, whether it's cancer or rehab due to addiction. Mediating these groups is hard. And so we did some really interesting stuff. Elaine Short and ages before in my lab did a study where the robot didn't even understand what the people were saying, but it just kind of looked at their body language, and it did a really effective job at mediating. So it doesn't even matter what you say. Then now with language models, we can both understand and talk in real time. And we find that these models are perfectly capable of serving as mediators. I'm not surprised. But it turns out when you ask people, if you tell them it's a model versus it's a human, they behave very differently. So again, I think people will be tweaking this, they'll be lying, they'll be saying the human is controlling it, but they will actually be using a model behind it, and vice versa. You hear a lot about autonomous cars, which are being actually teleoperated a lot, and autonomous robots that are being teleoperated a lot. But our expectations and how we behave are very different. So why I bring this up? I bring this up because when people are doing data collections for model training, people fake all kinds of things, and they think it doesn't matter, but it does. Right? So if you're just doing blind teleop, like whatever, it's actually, the data you're collecting are not worth as much. If you're just driving a thing in a neighborhood where everyone is used to it, or where it's a bunch of college students who are not behaving naturally because they're college students, there's nothing natural about college campuses, right? So these data collections that we're doing for model training these days, they're so biased and they're so limited, and we're not willing to admit that yet. I'll get to it. Okay, so what else foundation models are not good at? This is my foundation model bashing. So for this work of having real humans with real challenges talking to a robot, whether simulated or real, for support groups, we collected a bunch of data. So we wanted, of course, to annotate the data automatically. This is a huge challenge in social science and also these days in model training. You want data for anything supervised, you need annotations. Where do the annotations come from? They come from taking humans and making them stare at the screen and paying them minimum wage. First of all, the annotation quality you get out of that is also questionable, but we call that ground truth because it's humans. But humans only behave well when they're highly motivated. So that's a whole other thing about the value of MTurk data. But these are the interesting things. So we thought, we'll just use foundation models to annotate these data. But we wanted to see how good they were. And so this is literally, we just submitted this to a conference, I won't say which one, but we did a large comparison. By we, I mean my students, Mina and Caitlin, did this wonderful study where they compared top of the line, closed box, models like Gemini and so on, and then, more open source models compared to smaller deep models in recognizing the emotion and the engagement in human-human interactions. And let me just tell you, as of 3 days ago, top-of-the-line foundation models, instruction-tuned or not, they are terrible. They are awful at understanding what feeling they're expressing. Are they engaged in this interaction? So this is really interesting. The models are trained on a ton of data, and yet they're awful at understanding social cues of humans, which, by the way, is super important, because if you want to put them with people, this is going to be needed. Models are also terrible at spatial reasoning, right? They can't do mental rotation. They can't tell what's next to what. Fine. That's the physical embodiment stuff. This is the social stuff. They're just terrible at this. I was surprised how bad they were. And so you might think, how important is this? Well, it's very important. But I just want to kind of tell you about other things that knowing what's hard and what's easy is often a surprise. Do you think it's easy to tell when someone is lying? Okay, so first of all, let me tell you, in case you didn't know this, you personally are only at chance level. If I showed you videos of people lying versus telling the truth, you'll be 50-50, coin toss. You'll be terrible at it. Shockingly, people are biased to believe things. I know this is hard to believe now in the age of, everything, social media and such, but we're actually wired to be biased to believe. And so we're terrible at detecting lying. You can get coached and trained. There's the fax coding for facial expression reading that often police officers are trained in, and then they get to like 65%. Woo-hoo, not impressive. So at some point, I had a really, really smart student in my lab who was interested in affect, and I said, well, why don't we look at deception? I was interested in deception from people like lying about whether they're feeling bad or not, because we wanted to deal with people with anxiety and depression, and I'll get to that. But how hard is it to detect that someone is lying? It turns out with deep models, small deep models, not foundation models, it was really easy as long as the data were multimodal. Single modality like vision only, not very effective. But once we did a combination of video and audio and transcript, Lena was able to do a fantastic job of this. This is all deep models. This is all pre-foundation models. You do this with foundation models, not so good. In fact, quite bad. I should also say the police were very interested in this when she presented it. She was surprised. But anyway, machines are really good at detecting lying, FYI. Does that make you nervous? Just saying. On the other hand, machines are terrible at detecting your emotions or whether you're actually engaged in a task. So these are images from a movie that I highly recommend everybody watch, and it's called Robot and Frank. No one's seen it because it's kind of like a sleeper when it came out. It's an excellent movie about robotics. You should see it, Robot and Frank. But anyway, this is an example. On the left, not engaged. On the right, engaged. Okay, it's also physical, but it doesn't have to be physical to be engagement. Engagement is really complex. It's the billion-dollar question. Every company out there wants to understand and predict engagement. Because if you could predict how to engage the user, how to keep their eyeballs, well, that's the thing everybody wants. Oh, but it turns out we can't. And it's really hard. Because why? Because it's individual and it's complex. It depends on the context. It depends on all of these signals, eye gaze patterns, head direction, facial expressions. You think it's generic, but it's not. Everyone is different. And then some people are even more different than others, like individuals on the spectrum, for example. So we're really interested in this because we want our robots to understand people in real time, to understand their feelings, to understand their drives, so that we can help them. In the moment when I am with a disability trying to grab this and I'm getting really frustrated and about to quit, I want the robot to know and say, hey, you could do it. Just do a little more. Okay, so how do we pick on that? How do we do that? And so that's why we work with really hard populations like individuals on the autism spectrum. Super interesting, right? I'm going to just say this to the students. It's less impressive to take a standard data set that everybody and their cousin has already used and pick on another feature of it. Try and work with something really hard, like the behavior of individuals on the spectrum. There's a huge amount of variance across and within the population. So within, like across kids with autism, there's just giant, you can't average. But even within subject, the behavior across time varies a lot. So this is what makes it really hard to make personalized models, but you need to. And you can say, oh, I don't want to deal with that problem. Well, maybe you should, because it's 1 in 36 children today, and it's more than quadrupled over the last 20 years, and it's continuing to rise, irrespective of what some people would have you believe. So this is not going away, and in fact, it mirrors a lot of other behavioral challenges, including ADHD, anxiety, depression. You have these very personal, what do I want to say? It's like a spectrum. It's like a combination of symptoms and severities. And it's different for everyone, and it changes over time. It's a moving target. Super interesting domain to work in. So we did that with autism, I want to tell you, because it talks about deep models and also language models. So we deployed, thank you, NSF. We had a NSF expedition over many years, and we developed and deployed in collaboration with Yale Scazzolati Lab. We developed these robots and deploy them in homes of families with children with autism for a month plus. No one else had done that before. Not even a company had done that. And then we collected data in daily interactions with the robot. I just want to play a little clip, which I have a dream will work. Oh, what? Okay.
Meet Adrian, age 6.
This is some great work.
And his robot friend, Kiwi.
You are doing an amazing job.
On this weekend morning, they've settled in to play some games, along with Big Brother Darren. Adrian is on the autism spectrum, and Kiwi is no toy. It's a socially assistive robot.
You are doing really great. Keep up the good work.
So I stopped that because then it shows me and you don't need to see that. However, there's a nice long video on the web that has a lot of interviews with students who worked on this. It was like a giant village of students. To create a system that will stay in someone's home for a month, not catch on fire, not stop working, that's a whole other thing when you're not a company, and even if you are. But it was really interesting to see what does it take to understand enough about the child's behavior, to interact with them in a way that is generative, this is before language models, and then to track and adapt their behavior to keep the level of challenge going. So there's several things that I want to point out here. First of all, engagement. How can we even tell if the kid is engaged with the robot? We can't. No one can. Is the kid looking at the robot? Well, maybe that's not a good indicator. For a lot of people on the spectrum, maybe looking out of the corner of the eye is how they interact, because looking straight on is too complex. I don't know. I have to establish a baseline model of the individual. So no generic model will work. First problem, right? Because most perception models are like, you take a generic model, you take it. No. So you have to personalize. So we did a bunch of studies on how much data you need and what modalities to even be able to tell if the kid's even interacting with the robot. I mean, maybe they're looking, maybe they're talking. Are they engaged with the task itself? Are they engaged with the robot? This is really critical because we're trying to teach them social skills as well as whatever the task is. So a lot of really interesting stuff, papers in good places in terms of just determining how the robot should move its head and where to look in order to capture and hopefully hold the attention and the engagement of the user. Next thing, speaking of the variance in the data, which any interesting data set will have, and all of the boring ones will not, there's not a lot of data in autism. So you'll have to work with whatever data you're getting from the user, because each user is different and changes. But then you also want to work with the available data sets. And so how you do this transfer learning from small, sparse, noisy data to another set of small or maybe medium-sized data set, which are also noisy and different. And so Zhonghao Shi did some really beautiful work along with other folks. And this remains a really interesting question because right now, today, with big models, so what do we have? We have a generic big model, and then we have data that we fine-tune with. How much data? How often do you fine-tune? Again, these are really open questions right now. People are actively churning out papers. And all I would say is when you're churning out these papers, try to at least work with interesting data sets. Because it's really an open question, right? So if right now, I wanted to repeat this with foundation models, would it be any better? It would not. I was telling someone about this. This will be fun for people. This is always fun for students. I was talking to Dario Amodei, who is, of course, the CEO of Anthropic, at some event. We don't hang out regularly, I know, in case you want to be impressed. But we were chatting, and I said, do you believe that just one giant big model is going to be good at this stuff? Like, for example, data with kids with autism. And he said, oh, absolutely not. This is all going to be out of domain. It's really hard. The balance between small models and big models is always going to be attention, and who knows, what you do. And it was exactly the right answer. And also, when you use a big model today, like when you go and you use like Google's model, or if you use OpenAI's model, and you have this image that it's like one big model out there that's been trained on, it is, but also you have no idea how much more machinery there is on top, how many smaller models are being used, how much additional reasoning and pre-processing is happening. A whole lot. So I think in many cases in academia, we kind of end up thinking that it's like the model, and you just use the model, and maybe it's zero shot or few shot, but that's it. It's like, but in commercial worlds, what's under the hood is incredibly hybrid and complex. And I just want to say, like, this idea that some people keep putting forward about we will just have one model to rule them all. No, not likely. But just for pragmatic reasons. And that gets us to these interesting questions about how do you represent different types of reasoning? Is everything going to be a collection of small and big models? Are there going to be some, additional, people are thinking of new architectures of representing knowledge, neurosymbolic. I mean, it's not my world. but it's important to understand that don't over-index on this idea that it's just going to be one model to rule them all and that it'll be like the models that we have today. No, people are actively working on the next thing past transformers, and they should, because we're so far from done. So it's just really important. And think about that when you're writing papers, of whether you're spending too much time evaluating today's models, because they're going to be different. Nobody will care in 5 years. Literally nobody. I talked a lot about social stuff. Not everything is social, right? There's the physical component. Nathan, again, because Nathan's on the job market, I love to present my people who are in the job market. Beautiful work combining social and physical feedback. So Nathan worked with kids with cerebral palsy as well as stroke patients who have serial physical differences, and they need to regain physical skills or gain physical skills. But you can't do it without the social. You have to want to, and then you have to keep pushing through failure. So these are really interesting questions at how you do that, bringing together feedback across all of these different systems. No foundation model can do that today. This is more of an RL space kind of thing. Speaking of personalization, again, going back to the kids with autism, so if you have a system for a month in your home, sorry, this slide was meant to be earlier, it's not just enough to try to understand if the kid is engaged. So they're playing this interaction game and they're looking at the robot, they're learning eye gaze. What do we do about the level of challenge and the level of feedback? So if you know about intelligent tutoring systems, which have been around for a long time, what they do is they adjust the level of challenge. Like let's say you're learning, I don't know, some kind of math. They're going to give you a problem. You're either going to get it right or not. Then if you get it right, they'll give you a harder problem. If you don't get it right, they'll give you a slightly easier problem. They're adjusting the level of challenge and keep trying to challenge you to learn more. Well, that's no good for people who are constantly failing. What are you going to do? You're just going to be like, wrong, 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 wrong. How fun is that? How long do you think they'll keep interacting with the robot? Not that long. Or conversely, if you're doing great, right, 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 right. How exciting is that? I mean, if you have a big ego, it'll keep you going for a while, but then it's boring. So you have to really think about not just the level of challenge, but the feedback. And it's all about the feedback. It's like, what does the robot say and do to keep the person challenged? Sometimes you tell people that they're doing better than they are in order to get them to keep trying. When we used to work with stroke patients like 20 years ago, we saw stroke patients cheating in order to get through the task because it was so hard. If we told them every time, "Wah, you cheated, stop cheating," that's not rewarding. But what we did do was we had the robot say nothing and tell them they're doing well. And then next week, when they came back for the next session, we would have the robot say, "By the way, I knew when you were cheating." So that was awesome because then people were like, "My God, the robot is smart." You know, it's just a small trick about human motivation. But all these levels have to keep being adjusted. That's personalization. And understanding what's more important. Well, it turns out it relates actually to personality. So extroverts like more challenge, by and large, statistically speaking. Whereas introverts might like more positive feedback. So these things all interleave when you're trying to personalize. So I think, in the bigger picture, the way I think about this is I think that obviously the future of all of this is very personalized and adaptive, right? And so what does that mean? That means that we first need to collect data in real interactions so that we can understand these dynamics, which we're not doing right now. Most data collections are pretty passive. Then we need these probably smaller deep models, or maybe foundation models, in real time to understand what's going on. And then we have to keep adapting. So there's going to be RL as well, because obviously the model itself is not going to change anytime. So you'll need RL so that the system will keep adapting to the user. So all these things will be necessary. There's going to be a really interesting interplay between these large and small models and reinforcement learning for any system that interacts with humans. Like we talk about agents. What do you think agents are? Agents are systems like that sit on top of foundation models that keep memory of your interactions with you specifically. They remember you and what happened, and they adapt to you. Or at least that's what they need to be doing. They don't do it very well yet. All right, so now I want to end with the stuff that I really care the most about. So we're really, really interested in, we're always motivated by big challenges that people are having and hoping to insert the robot to help, right? That's always my dream. I have a robot to help you with that. Not an app, a robot. So in the last few years, I've had students who've gotten very, very interested in sort of neurodivergence, so ADHD, but also particularly anxiety and depression, because it's extremely common now for everybody. So how do we work on? So we worked with ADHD. We did this really fun thing, I feel. So there's a therapy in ADHD that's called body doubling. And it turns out that for individuals who have ADHD, which is a lot of people, if there's someone else in the room, they focus better. That someone else doesn't need to tell them what to do, doesn't need to keep them in line, doesn't need to nag them, just another human in the room. It can even work online, doesn't work as well, but there are these things called study videos where people study watching a video of someone else studying. So this body, like the co-presence of another human is really powerful. By the way, it doesn't work with like a software agent on the screen. I wonder why. So we wanted to see, well, if you can't study with another human because whatever, you can't, it's COVID or something, could a robot do it? And it was really interesting. The body doubling effect was actually very effective. People liked studying with the robot. We left it in the dorms for a while. So that was interesting. It also turns out it has a regulating effect on the emotions of the people who are using the robot. And this is where I want to get to the big thing. This is the thing I love. So put up with me. Oh, I'm not there yet. Sorry. This is not, I mean, I love this too, but this isn't the big one. So first of all, you guys have been watching this and you're like, why is she using these robots that aren't really robots? Where are the Canova arms? Where's the real robotics? Well, first of all, this is all real robotics. Make that robot move in a way that people perceive as moving in that particular way with that form factor, which is squash and stretch, and it's very difficult to both control and then predict. It's all robotics. But more interestingly, if we're going to get robots into the real world, they have to be affordable so we can get them out there. They have to be replicable, so they have to be robust enough so I can have a bunch of them and I want to swap them out and they need to behave the same. And I want it to be flexible, so it should have different affordances. I don't want to buy one arm that just does what it does and that's all it does. I want a robot where sometimes it has ears, but maybe it has horns or it has nothing, and maybe it has little things you touch and then it's got your EKG. But if you don't touch it, then maybe it's just using color. So we developed a really low cost based on the Cornell robot Blossom that was done like 20 years ago. I saw that 20 years ago and I was like, that is cool. And Guy Hoffman said, oh, I had an undergrad do that, whatever. And I was like, I like that. And now, many years later, we've taken that, we changed everything about it, but theirs was the starting point, so I give them credit. These are really low cost, $300 if you can crochet. That's a big if. No one can crochet. A lost art, really. My student, Amy, can crochet. You can knit it. There are knitting machines. There are even cheap knitting machines that you can get for like $20 that like you crank them and they knit. But the crocheting is much better because it's literally a soft robot. And so super cheap. So we've got colors, LEDs, fiber optic cables. We've got EKG sensors on the outside where you just put your hands on the robot. It's collecting EKG. It's not super high fidelity, obviously. But that's fine. I want people to just be in their dorms and interact with this naturally, and I want it to be helpful. It also has, conductivity sensors, so you can tell when you're touching it. It has breathing, so we do breathing exercises. Okay, so now let's see where it's going. You guys have to stop talking. I'm extremely into being the only one talking. Thanks. All right, talk later though. Okay, so I want to go back to my whole thing about apps. Is there an app for this? Okay, there are 7 bazillion apps on mental health, right? Cognitive behavioral therapy, most popular thing. People think cognitive behavioral therapy is kind of a set of rules. It's a playbook. So we can just prompt an LLM with those rules. We put a little benchmark around it to make sure it doesn't say stupid things, and it'll solve your mental health. Yay. And also, by the way, please subscribe monthly. Wow. So we thought, wow, well, if that's true, let's try it. So we did. We tried this already 2.5 years ago with GPT 3.5. Has not changed. We benchmarked it since. If you put cognitive behavioral therapy rules and you say to an LLM, administer cognitive behavioral therapy, and you get into an interaction, it does a great job. CBT is so common, it's so well known that just your regular trained model can administer it quite well. Okay, are we done? We don't need therapists anymore because we have this. My university is currently recommending that we use ChatGPT for mental health. Well, so we wanted to find out how well this works. And we actually took some real measures because here's an interesting fact. And I love to say this to everybody. Do you know what the best predictor is of the success of mental health therapy? Okay, is this thing going to work? Is it going to help you? Do you know what the best predictor is? You might think, well, maybe it's whether I find a therapist who does exactly the kind of therapy that works for me, like cognitive behavioral therapy, dialectical behavioral therapy, breath work, Jungian, Freudian, mindfulness. No. According to hard science that I did not do, the best predictor of whether you personally will be helped by a particular mental health therapy is your alignment and synergy and entrainment with your therapist, a human therapist. So for any given pair of people, a therapist and a client, how they interact is the predictor of how well you will do. You don't want to believe that because you want to believe that it doesn't really matter. But seriously, are we surprised by the fact that the relationships between people are predictive of our mental health? So this is really interesting. So we actually went through, read a bunch of literature to see how in therapy this alignment is measured. And then we found computational ways of implementing that. And then we evaluated it. We evaluated human-robot interaction versus human chatbot interaction. And we found extremely low alignment with human chatbot. We were like, surprised by this because we even looked at alignment or entrainment between people arguing on Reddit. So Reddit is full of like massive arguments on all kinds of things. This is, as far as I can tell, the purpose of Reddit. So when you're fighting with someone on Reddit about something, guess what? You two are deeply aligned. You're very you're into it and you're both enjoying it because rage is a very pleasant thing when it's happening. As it happens, you're changing nothing about the other person. They're not hearing you. You're not hearing them. You're just raging on. But you are totally entrained. It's working. By the way, getting that in therapy, if you could get that sense of I want to do this back and forth, you would really recover fast. That is very rare. That's what we're looking for. That's the determinant of whether you will get better, being that motivated. Except unfortunately, we feel that motivation rarely, like that flow. You rarely feel it for positive things. Oh, but you readily feel it for negative things. Okay, so we don't want negative things, but we can show decisively that alignment is really low between therapists, chatbot therapists versus human therapists, or even human, non-experts who give advice. But the ultimate test is not whether a computational measure does it, but whether a person gets better. So we ran a study. And now it's a clinical trial by NIH with hundreds of people. And we compared chatbots versus having the chatbot talking through the robot, that little cute Blossom robot that I showed you. Short answer, we did this with university students. Short answer, you will be totally happy using a chatbot. You will use the chatbot, you will enjoy the conversation, you will feel that it's listening to you, and your psychiatric distress will not be significantly reduced. You do the same thing with a robot, and your psychiatric distress is significantly reduced. What is going on? The only difference is the physical embodiment of the robot. That's it. Nothing else. What it says is the same model behind it. Back then, 3.5. Now it could be Gemini. It could be Gemma. Who cares? That doesn't matter. CBT is so textbook. I'm not impressed by any company that produces a chatbot for CBT. My undergrads can do that in a day. So what is going on? Why is it that when you deliver it through a robot, it works totally differently? And by the way, how do we measure that? We measure it with a DSM measure that is used as a clinical diagnostic. Okay, so not like, do you like it? Sorry, you may like it, but it's not really helping you. So you need a clinical measure, and we're using clinical measures. This is really interesting. This I really want to emphasize when I get you to think about technologies. When you think you're creating something that really makes a difference. It's awfully easy to create chatbots and all kinds of things. But whether they're actually helping, first to measure that is very non-trivial. And people use all kinds of Likert scale subjective measures. And you have to remember that when you're giving someone a Likert scale measure in a study, you paid them to participate. So it's a whole different thing. This is very interesting. So I just want you to think when you're creating your, whatever it is that you want to do with your degrees and your future steps, keep a few things in mind. Human-machine interaction has real value. It can change people's literal life trajectories. Remember the babies. We can tell We can help the baby not be literally disabled and have an issue, right? We can help people recover. We can help people on the autism spectrum. We can do all of these things. They've been shown and they work. We can also create a bunch of things that make us feel good and possibly make a lot of money and not only not help people, but actually do the opposite, create a lot of harm by making people believe that they're helping, but they're not. So I just want you to take away point. Work with real, meaningful, real-world problems. You can. You can choose to work on this. Your advisor will be happy. You'll be happy. Text in real-world context, by the way. Spoiler, anything you do in the lab is not real. You have to do it. You have to test it. It ain't real. Get out in the real world. It's so much harder because it's real. And then finally, try to think about enhancing versus replacing human abilities because it's the stuff you're going to do. It's your world. It's your future. It's your next few decades. So what are we creating for people? And by the way, it's so satisfying when you actually create these technologies that help people. The payoff is right there. It feels great. So when my students are working day and night, at the other end, they feel really, really good. That's why I do it. It makes us feel good. So I do want you to realize we're in a really amazing time in history with AI. And there's a lot of potential. There's a lot of power. And there's a lot of risk. And so acknowledge the risk, choose wisely, go do great things. Maybe help people, I would suggest. It would be great. We can. And yeah, be awesome. Like all these wonderful people who helped me give a hopefully interesting talk. Thank you. Do we have time for questions? Yeah. You have to ask me questions. Otherwise, what was this for? Yes, thank you.
So,
not a student.
I think somewhere in the talk you talk about the LM is good at detecting the deception, but it was not very good at taking facial cues. So what's the difference?
So no. The deep models were good at detecting deception. Not the LLM. So that was work with actual deep models. I suspect it'll be good though. So that we had, actually just to clarify, the data set that we had, that we trained on, was actually court testimony. So there was labeling. This is really interesting in court testimony because then you know if someone was lying or not, right? So these were really well labeled, well annotated testimonials. And we trained small models on that and they were super predictive. So the LLMs are not going to be as good, but they may be quite good. The affect is much more complex, right? Because it's different. It's a different scenario. Things are not trained for, you would have to train LLMs on every possible social scenario, which is a little bit what I'm advocating for. We need a lot broader training for these things. Otherwise, they're just terrible. Does that help? But I cannot tell I cannot answer the question of how good is, let's say, Gemini at deception detection. We haven't done that bit. But the small models are really good.
So those have to be VLM models because you look at both the image and the text.
Yeah, so they're multimodal. Well, that's what we found. I mean, you could test it now and see if it's any good, but I don't expect it to be good because even for small models, we needed multimodality. And that's a general thing. There's an entire, conference, ICMI on multimodal AI. And there are a bazillion papers that show that multimodality gives you an advantage. It's harder, but it gives you an advantage because we're multimodal processors, right? Thanks, yes?
Did you discuss the benefits of having the robot in the house with the children on the spectrum?
Oh, gosh. Well, I did a startup on that, but then, had a bad CEO, so that's over. So what are the benefits? In general, I would say, first of all, general thing, people should take care of people. Why? Not only because it gives people jobs, but because we really want people to take care of us, right? We're wired for that. However, you can't always have that. So, Elon Musk has 19 children on the spectrum, and they have a PhD level person that was there for their kids for the first 5. Not everyone can afford that, to put it mildly. So what happens is, for example, for children on the spectrum, one parent usually has to not work, so that they would drive the kid to their usually occupational therapy, speech therapy, psych therapy, a bunch of different therapies. And then they're supposed to practice at home. So how do you learn to behave normally socially? You play with other kids. When you don't play with other kids, you don't get training. No skill happens in a vacuum, right? You have to practice. So we're actually seeing that. We're seeing, especially post-pandemic, that social skills of kids are delayed. because they haven't gotten the practice. With kids with autism, it's harder because they don't have the natural predisposition for social skills. Many of them, not everyone, of course. And so often they also get bullied. They don't get the exposure to train because other kids won't play with them. So the idea of these systems is to provide practice that they might not get in life. Ideally, the robot is cool and maybe another kid comes and now it's like a triad. That would be ideal. It's the same as cognitive behavioral therapy, right? You got to practice. So the robot gives you a safe place that's also hopefully engaging to practice. Same with stroke rehab. You got to keep practicing. It's demoralizing. It's boring. Who's going to do that with you? That's the idea. Does that make sense? But it's not meant to say, oh, well, now you don't need other friends, because that would be a terrible outcome. I don't know if that gets at your question. But that's...
more of the results from the...
Oh, yeah. So, okay, yeah, sorry. I did not mention that. Okay. So we left it in so we did 2 parallel studies. The folks at Yale did their study with Jibo, left it in the homes for, I don't know if you guys remember Jibo, but Jibo was a cool, the whole company was called Jibo, a cool social robot. And then we did ours with that lab-made robot so that we can impart control for embodiment. And we found that in both studies, the kids' social skills and cognitive skills improved, and that some markers of autism behavior were diminished. Like they got better at eye gaze, they got better at turn taking, right? Now, if you take the robot away, those skills will decline, right? They have to keep practicing. But in both cases, those gains were made. There were some children in both studies, though, that it was interesting. They liked the robot, but they didn't necessarily improve, but they formed like a bond with the robot. So we had to give everybody a little 3D printed replica of the robot because we couldn't leave the robots. I mean, they're expensive and they're not safe. But just taking them away was cruel. So we had to give the kids something. So it was very promising. And there's a lot of interest in the behavioral health community for autism in particular, for robots. In general, in therapy, people don't love technology, right? Therapists do not like chatbots. Occupational therapists don't love robots for other things. But for autism, it's such a large and complex problem, and no one has any real answers, that there's actual interest. So there will be more products. I think foundation models actually make this a lot more possible because you need generative conversation, and they can do that. Yes?
I'm used to thinking about a lot of these problems more from like an engineering data, like science point of view. But when you work with these populations of people on spectrum or like patients at hospitals, what's the biggest challenge to get everything done? Is it to get people to cooperate, to be interested, or is there something that you guys do in the lab that's very hard? I know it's kind of hard to pick one.
Yeah, there's so many challenges. How do I pick one? I'll give you an example of a study we did. It's probably one of the hardest. The autism one was really hard, but everybody was motivated. I mean, obviously people in the lab are motivated, but the families were really motivated. We did a really hard study. This was, I don't want to say like 18 years ago. With Children's Hospital Los Angeles, they came to us, actually. A doctor came to me and said, I'm interested in reducing the experience of pain in children who get injections. She said, I read a study where kids who were getting flu shots were allowed to play with the robot, the Now robot, and that made their experience of pain less. And she said, can we do that for IV insertions, for kids who have chronic issues and they have to come in, like maybe they're getting, a chemotherapy or something, right? And so when she came and talked to me about this, my first answer was that a flu shot versus an IV are totally different, right? If you've had both, then you know. A flu shot is nothing. It's like that. So you could be distracted by a robot for like 3 seconds at this, like 2 seconds. An IV is way worse. More pain, takes longer, the anticipation. So I said, I don't think distraction is a good mechanism. But of course she said, what the standard of care is? We give kids videos. That's distraction, right? So we went in actually to go into the hospital. Oh my God. So we're going to bring a robot into the hospital. First of all, the robot had to be fully plastic because everything has to be wiped down. So you can't take a robot into the hospital that has like anything. Can't be crocheted, can't be furry, no. It has to be plastic and it has to be wipeable. So finding that was a pain. Then the network, the hospital has its own local network. Oh my God, can't get on the network. The network is crappy. We need our own hubs. Oh, can you bring the hub? Oh, I don't know if it's safe. Oh my God, the security, totally like things like that. Another one was we wanted to collect data, we wanted calibration, right? If I want to collect data about how the child is responding to the robot, the camera has to stay in the same place. And we had markers on the floor. And every time they would move the camera, it wouldn't get put in the same place. The video is not calibrated. Oh my God, things like that. But we did do a wonderfully small study, and we found that we actually had the kids play with the robot as a distraction versus have the robot actually tell them what's going to happen. You know, like some kids really want to know what's going to happen when the needle goes in. I do not. Like, I'm not the person that watches, but some kids really are. It reduces their anxiety because they know what's happening. That works for some people. For other people, it's more soothing. That's more me. I'm like, pet me and calm me down from that terrible thing that's going on. So people have different ways of calming down. And what we found, again, personalization, what we found was we could figure out from the kid which one they preferred. And then we would give them that. And it really did significantly reduce their experience of pain. In an IV insertion, which can take up to 10 minutes to do right, so it's a lot of... And more interestingly, we benchmarked it against the standard of care, which was just distraction with videos, which made the kids actually feel more anxious. Because it goes on, right? A flu shot is fast. This is like, oh, there are doctors coming, you're going to be okay, we're going to bring and then there's this thing, and it's like going on forever. And that anxiety of anticipation is really hard for the kids. So I think that's an interesting problem, because in the real world, anxiety is ongoing. It isn't just like a shot and you're done. I don't know if that helps to answer the question, because it's a lot of barriers, a lot.
It makes sense, yeah, definitely. A lot of coordination.
It's a lot, and it's the same thing, like when I did the startup, we had to look at things like, even like FTC regulations on putting robots in homes with children and things like that. And like if you look at products, you guys wouldn't remember this, but a few years ago, I think it was during the pandemic, Amazon came out with the Kid Alexa. So it was like an Alexa that was just for kids. And of course, it was impossible to control because you don't know where people are going to put it in the home. Maybe there's another Alexa that's happening. You don't know who's hearing. You're collecting child data because, if you think they're not collecting data, right? So it's really complex. They ended up pulling the product because there's just so much liability around children as a protected category. So that's a part of the reason why you're not seeing a lot of in-home stuff, because people are just worried about liability and approvals. Having said that, for example, the seal robot, the Paro, that was developed in Japan like 25 years ago, it's literally a stuffed seal. It moves its head and it screams. I screams because seals scream. It's not a lovely, soothing sound. That thing is FDA approved for being a biofeedback device. It is no more a biofeedback device than a stuffed bear, in the sense that when you pet a furry thing, you calm down. That's a thing. Don't chuckle. So, same thing. So it would work with a stuffed bear. It would work with a stuffed seal that's not actuated. They never did the comparison study because it doesn't need to move, right? The biofeedback is just from the petting, right? So there are ways of getting into the ecosystem. There are people at the FDA now, well, I don't know about now, but like a year ago, there were people at the FDA who were very AI friendly, who want to see these products get out. So I think the pathways are there. But right now, the issue is all the money is in humanoids and manipulation. That's where all the money is, right? So that may change at some point when people realize the marketplace in the home. But, like autism is a huge market. And it will be, stuff will happen. But what's sad is that it's taking forever. And literally, millions of kids are growing up without things that they could have and could have had years ago. Other questions? No other questions? Yes.
Are there any companies or labs or just people in general that are like, if we're interested in this field and like would want to be in it, like that we should look into like joining your lab?
Yes, my lab. I take volunteers anytime. It's true. So there are, it's a really good question, because as I just said, most companies are now able to get money only if they're working in the space of humanoids, a little bit of logistics for warehouses, but that's about it. So yes, there is a new company. I will recommend Google it. It's called Familiar Machines and Magic. So they're doing something interesting. It's the guy who did iRobot, but iRobot is no longer. So he's the one guy that put 50 million robots into people's homes. So might be able to pull something off. And then there are a lot of small efforts, in particular in Europe. There are the robots that people mostly, like their entire market is other academics. That's not a market, right? If your product is only going to be purchased by professors, you can't survive as a company. So it's a small space. There was a bump for a while. There were a bunch of companies like Blue Frog Robotics came out, Jibo came out, Embodied, that was the thing I did, came out. A bunch of companies kind of came out, they were funded, and then they all went away, and now it's all foundation model stuff. But I think it's going to happen again because these foundation models are very enabling for social and socially assistive robotics, right? You get talking for free. So I think now is just like getting VCs, if you're going to be venture funded, to understand that this is a space to go into. Personally, I wouldn't go. I'd go for a nonprofit and get a philanthropist and go there. But you're not asking how to start a company. You're asking how to get involved. Familiar Machines and Magic has a local location. So I don't know. Email me. I'm working with them because they're doing the right thing. That's one I can think of. I wish I could think of more. There was something called Tombot. There was right? Yeah, does that exist still?
Oh, yeah.
Tombot, there you go. That's a dog. Anything else? What am I forgetting? Any other companies like that? Yeah, see, it shouldn't be this hard to think of it. But anyway, they do exist, and don't compromise. If this is what you want to do it. Any other questions?
I think we're running out of time.
We're done. Oh, there's a question. You can come over and ask me later, or ask me now quickly.
So obviously AI is rapidly advancing. So my question to you is, do you think we can guarantee our control over AI and robots, or do you think there's going to be a time where they can advance so quickly that it's out of our control?
Well, that's a really good question, and it's almost like a philosophical question. There's a whole world, I don't know if you looked at, but there's a whole bunch of futurist philosophers, right? There's like long-termists who think about like what's going to happen like, thousands of years from now. And so nobody knows, and I'll say I personally don't love futurists, because the thing about being a futurist is you make predictions, and then you're dead, and so no one gets to call you on it. So I don't like that. But if you guys want to see some really nice futurist predictions by a real expert, I recommend looking at the annual blog by Rod Brooks, who is like one of the major experts in AI, also was my former advisor, but that's not what it's about. I would give him grief anytime. But what he does is he does this futuristic prediction on 3 areas: AI, machine learning, autonomous driving, and space. Okay, that's 4. He did those. He also did quantum and then decided he doesn't know anything about it and quit. I respect that. You should know what you don't know and be honest about it, right? So he does an annual prediction, and he looks at 5, 10, 15 ahead, because nobody can tell even 5, much less 15. Then he comes back every year, including now it's been more than 5 years, and he checks his predictions, and he scores them. Who else does that? Show me another futurist who is actually willing to be benchmarked against ground truth. Not a single one. But Rod does that. So I would say, look at his blog. It comes out annually. I think it was even referred to in the New York Times, but I don't know. Anyway, just very easy. Rod Brooks, annual predictions, whatever. So I'm not going to be a futurist like him do it. But I would say when I talk about this to people, I think it is totally up to us how we manage this. So I think, if you think of AI as like, oh my God, I'm creating something and I just want to see what happens. And if you think of the world as your playground, the way certain CEOs think, right? Like we're creating a thing, we're going to throw it out into the world and see what happens. That's very dangerous, right? As opposed to thinking carefully about, like nuclear power, let's say. There's always an analogy, right? Should we consider that this is like nuclear power and think about regulation and thoughtful, or should we just race and hope for the best? And we're kind of in the latter regime right now. But Europe is getting worried, and they're pushing against it. It's a complicated world we're in. Usually when you have a company, they don't like to have a different set of operations for Europe versus the US. So like Fitbit has rules from Europe that now apply to the US. It's a part of Google, because you don't want to make 2 sets of products. So I think if anybody takes this seriously, it could have an impact. But if no one does, yeah, there are a lot of risks, because we get to drive where AI goes. And I know you're talking about, well, maybe someday it'll be sentient. This is up to us today, whether someday it'll be sentient and take over. And if we keep driving it with no concerns for that, then yeah, it could happen. I still think right now we're still in control. But, I mean, if we don't care to stay in control, then we won't be. And it's hard to be in control if you're racing like crazy in a competition at any cost. So that's my take. But I recommend looking at Rod's stuff. Thank you.